All right. So the entire unit, we're dealing with systems, and we're going to start the first half of the unit talking about systems of equations. And then the second half of the unit will be systems of inequalities. So we're going to get a definition of systems of equations. And a system of equations is just two or more equations. So two or more equations with the same variables. Two or more equations with the same variables. Usually what that ends up looking like is like a y equals mx plus b, two of those equations, or maybe two standard form equations, ax plus by equals c. Now this says two or more. In algebra 1, we're only dealing with two. We will not look at more than two equations in one problem as we are solving these. And we'll talk about the solutions here in just a second. But algebra 1, we just deal with two equations at the same time. We'll never deal with more than two at a time. Algebra 2, if you get that far, if you decide to take algebra 2 in a couple of years, you will learn how to deal with systems of three equations, but that'll be in a couple of years. So when you solve for a system of equations, is in terms of a graph, which is what we're looking at today, it's a point on a graph. There's an x value and a y value, and that x value and the y value have to be shared between the two lines. And so if you think about what that looks like when two lines have a same point, it is where the two lines intersect. So if two lines intersect, that means they share that point where they cross. And so when you're looking at a graph and solving for these, you're trying to figure out at what point do the two lines cross. That's all we're doing today, is figuring out, we're going to be graphing two lines and we're going to find out, okay, where do those lines cross? What coordinate is that? And when you have that XY coordinate, that will be your answer. Algebraically, in terms of using algebra, which we will start doing tomorrow, if you are using algebra as opposed to a graph, you're looking for an XY that makes both equations true, and we'll talk about that tomorrow when we get to those types of equations. So a system is simply two equations in terms of what we are dealing with. It's just two equations in the same problem. Those two equations today, we will be graphing to find out what the solution is. And the solution is where the two lines cross. That's what we're doing today. So intersecting lines. So there are different types of solutions. It's not just going to be lines that cross each other all the time. However, that will be the most common. So intersecting lines are just lines that intersect at one place, because if you have two lines and they're crossing each other, they're only going to cross in one place. And so that point right there would be some x coordinate, some y coordinate. We'd figure that out on the graph. And that's what we're going to be working on today. Is basically most of the problems are going to look like this right here. They will cross, and we have to find out at which point they cross. The next one says parallel lines. And we made a definition of parallel lines back in Unit 4, and we said that parallel lines are lines that never intersect. And so if the lines never intersect and they just run next to each other always, that means there won't be a solution, because in order to have a solution, the lines actually have to cross. And so we can say, you could use the words no solution, or you can just say something like that. There is no solution. And I put an X through the zero because if you just put a slash through a zero, sometimes people actually write their zeros like that. So I'm just putting an X through it. So you can do this for no solution. You could write no solution. You could abbreviate no solution as no, and then SOL for solution, kind of like we abbreviated undefined back in Unit 4. And this last one might seem a little bit obvious, but it won't always be obvious when you start a problem. And sometimes you'll have a couple of equations that end up giving you the exact same line on a graph. If that happens, if you end up with the exact same line, it's just going to look like one line because it's the same line. And if you have two equations that end up being the same line on a graph, that means that every single point between the two lines is shared, not just one point. That means there's going to be an infinite amount of solutions. So we write the infinity symbol for infinitely many solutions. And we saw this infinitely many solutions and no solution. We saw those answers back in, I think, first trimester when we were dealing with just solving regular equations. It's a little bit different now in terms of how they show up, but those two answers are still available. So these are our options that we've got going on today. All right, get some notes here. All right. So solving systems by graphing, this is what we're going to be doing most of the rest of the class today. There should be time at the end of class to get started on the assignment as well. So there are three main or basic steps to solving systems of equations by graphing. And the first thing you want to do is to make sure that both equations are in slope-intercept form. So rewrite the equations in slope-intercept form. And just as a reminder, slope-intercept form, that is y equals mx plus b. We're going to graph these from y equals mx plus b every single time. All right. So once you have both equations in slope-intercept form, by the way, some of them will start off in slope-intercept form, which will make things a little bit easier. But if they're not, we'll have to convert them to slope-intercept form. Step 2 is to graph the lines. So graph the lines. That's step 2. And the third and final step is going to be identify the solution, or solutions if there's more than one. By the way, if there is more than one solution, it's not going to be two solutions. It'll either be one solution. If there's more than one solution, it'll be infinitely many. Those are your only two options for having solutions. Otherwise, it'll be no solution. Lines will either cross in one point, or they will be the same line, which means infinitely many. So those are your two options for having solutions. All right. So get your rulers ready. And we're going to start off with problem number 1. And if we take a look at both of these lines here, by the way, this little, it's called a brace. This little brace here is just identifying that this is a system. There's nothing special about that symbol. It's just saying like, hey, these two go together on the same graph. And we're going to graph both of them on this same grid down here. So first question, is the first equation in slope-intercept form? Is this in y equals mx plus b form? First one here. Yeah. Okay, so we can graph this one. What about the second one? Is this one in slope-intercept form? Yeah. And again, the way to recognize that is if y is all by itself with no numbers or anything over on the side of the equation with it, then it's in slope-intercept form. So if y is all by itself, then we can just go ahead and graph from slope-intercept form. So what is the slope of the first equation? Who can tell me that? Show of fingers or whatever we want here. What's the slope of the first line here? 1. Yeah. X is by itself. And just a reminder from last unit, the number with X when Y is by itself, the number with X is your slope. So slope is 1. And then the Y-intercept is right here, -8. So when we graph this first line, we're going to graph it. I'm going to use a red pen so it'll show up a little bit better. We're going to start with the y-intercept at -8. So I'm going to start in the middle of my graph. I'm going to count down 8 spots. 1, 2, 3, 4, 5, 6, 7, 8, -8 right there. So there's my y-intercept. And then I have a slope of 1. A slope of 1 means up 1 over 1, and then keep that pattern going, up 1 over 1. So up 1 over 1. And that just means it's going perfectly diagonal through all those points. And then we just take our ruler and we line it up and we draw our line through it. We did a lot of this back in the previous unit. So we'll get that lined up, draw our line all the way through like we normally do, and then arrows at the ends. And so there's our first line. There's our y equals 1x, or y equals x minus 8. So get that graphed on your paper. And then we're going to graph the second line, and we are going to figure out if and where those two lines intersect. Where do they cross if they cross? No Wednesday. All right. So we got that line graph. Yes. Yes. Cool. Yeah. Yeah. Right. So talking about Ash is talking about the pre-test from yesterday, those first couple of questions where there was the graph. What's that? What is it? Got it. Thank you. So the pre-test from yesterday, the two graphs at the beginning with the two equations, you know, the graph being there, it was kind of a clue like, hey, we need to graph these. So that's what we're doing today. The second equation here, we've got our slope of -2, which again, if you want to write this as a fraction, you can always do that by putting a 1 under it to get your slope. So -2 over 1 for the slope. And we have a +1 for our y-intercept. So this one we're going to graph starting at the y-intercept of 1. Right there. Make sure you can see that right there. There's our y-intercept at +1 on the y-axis. From that point, we're going to use our slope of -2 over 1. So we're going to go down 2 because it's negative this time. So down 2 and over 1. And then we can just keep following this pattern down 2 over 1. And you can eventually see where those two meet up. We just keep going down 2 over 1. And then we can line it up, draw our line through it, and then figure out what is that actual coordinate where those two lines are crossing. So we've got our two lines here, and we can see clearly that they do intersect and they cross right here. And so all we have to do now is identify what is this coordinate? What is that XY coordinate? And once we have that, we're done with the problem. So let's go ahead and figure that out. So this point here, if we go over, we're going over 1, 2, 3. So x is 3, and then we're going down 1, 2, 3, 4, 5. So y would be -5. So that is the point 3, -5, which is the answer to the system. So wherever those two things cross, wherever those two lines cross, that is your answer. That coordinate, that XY coordinate is your answer. And so that's pretty much what we're doing today. These first two problems, they set up a little bit simpler just because of they're both in slope-intercept form to begin with. So what I would like you to do is try number 2, graph those two lines, figure out where they cross. So problem number 2, graph the two lines, figure out where they cross. If you have any questions as we're going through this one, let me know. Come around and get some help. All right, go ahead and take a look. So the two lines, here they are. The y equals 1/2 x plus 9. We're starting up at 9 here on the y-axis, and then we're going up 1 and over 2. You can just use those 2 points if you want to. I went back 1 or down 1 and back 2 to get a few more points going back the other way, just to make sure I line it up nice and straight to see where those two lines are going to end up crossing. And then the other one is negative x plus 6, y equals negative x plus 6. That would be a slope of -1, and I wrote -1/1 as a fraction just to remind myself it's down 1 over 1, down 1 over 1. So we start at 6 on the y-axis, so up 6 and then down 1 over 1. And then we line it up and draw our line through it, and we get our intersection point right here. And that would be the point -2, 8 is what it looks like. So -2, 8 would be the answer to problem number 2. -2 and 8. That is the location where those two lines cross. All right, are there any questions so far? There's actually not a lot of new stuff today, to be honest, because graphing lines is something we've done. We just haven't put more than one line on the same graph yet. So really the only new thing is getting two lines on the same graph and then figuring out where do those two lines cross. What is that coordinate? Everything else is stuff that we have done before. So go ahead and make sure you have this down. I'll leave this up here for another, 30 seconds or so. And then we're going to take a look at the next 4 problems on the next page. We're not going to do the last 2. We'll just take a look at the next 4. All right, so taking a look here on the next page, problem number 3. So, somebody tell me, what is the difference here on number 3 versus the first 2? Good morning, thank you. Got our notes right here. And then if you don't have a pencil, I've got some up there, and then we'll need a ruler as well. Those are over by the calculators. Right by the calculators, just down on the, there's also some in the little basket up there too, in the bin. Yeah, and starting on number 3, we can see that not everything is in slope-intercept form, exactly. So we need to figure out what these are going to be in slope-intercept form and then convert to slope-intercept and then graph them. So for number 3, this first one here, we've got negative 3x plus y equals 8. We have to get that into slope-intercept form, and right now it's not in slope-intercept form. We have to get y all by itself. So I'm going to go ahead and rewrite this first equation right down here and say negative 3x plus y equals 8. And the idea here is to get y by itself. Now, what's somewhat convenient is that it's only going to take one step to do this. So what do we have to do here? Somebody tell me, what are we doing here to get y by itself? What has to happen? Okay, by doing what? What's the specific thing that has to happen to get y by itself? Yeah, like move this, get rid of the negative 3x. Yeah. Yep. And so to get rid of a negative 3x, what's the opposite of a negative 3x? Yeah, so add 3x to both sides. Good. So plus 3x here, plus 3x over here, which will give us y equals 3x plus 8. So that is our slope-intercept form for the first line. If we want to rewrite the slope as a fraction, 3 over 1, just to remind that we're going up 3 and over 1, that might be a good thing to do. So there's our first equation there that we'll end up graphing. We end up having to do the same thing with the second one, the second equation on this one too, because y is not by itself on that second equation. So for the second equation, we're going to have to do something similar. And instead of writing negative x plus y, I'm going to write negative 1x plus y equals negative 2. And so this is almost the same as the previous one. We have to get rid of that minus 1x. So we're just going to plus 1x, add 1x to both sides. And that'll give us y equals 1x minus 2, or 1 over 1x minus 2. And so now we have both of these in slope-intercept form, which means we can graph both of them at this point. So for the first one, we have our y-intercept up at 8, so that's way up here. And we're supposed to go up 3 over 1. The issue here is that there isn't enough room to go up 3 from there. And so if you remember back to unit 4, if we couldn't keep going in one direction, we could reverse the direction of both numbers. So instead of up 3 over 1, we can go down 3 and back 1. So that's what we're going to do. We're going to go down 3, 1, 2, 3, back 1. And we can do that a couple more times. 1, 2, 3, 1, 2, 3, 1. Just get those lined up. So there's our y equals 3x plus 8 coming into form, and then we can line up our points. Yeah. We get that line right there. And the other one says y equals 1x minus 2, or 1 over 1x minus 2. So this one we have to start at negative 2 on the y-axis. So start down 2 on the y-axis, and we're just going to go up 1 over 1, up 1 over 1. So this is another like perfectly diagonal line straight through the corners of all these points. And so what I like to do oftentimes is I keep using the slope in one way or the other, and then kind of figure out like, hey, this is where it's going to end up crossing. Because if you can identify that before you finish drawing both lines, it'll make it a little bit more obvious where that intersection is, especially if your graphs aren't perfect. It can make it a little bit easier to see where those two lines will intersect. So here's the other line. And you can see I kind of highlighted that point where those two lines cross right down there. And so we need to figure out what is that location. So from the middle of the graph, we're going to go over to the left 1, 2, 3, 4, 5. So that's -5 for x, and then down 1, 2, 3, 4, 5, 6, 7. So that would be -7 on the y. So -5, -7. That is where those two lines cross, which means that is our solution. So we've graphed both lines, we figured out where they intersect, and that location is the answer to that system. All right, we're going to look at 3 more problems, and then you'll have the remainder of class to work on the assignment. So here we go. Problem number 4. So this second equation right here, y equals -1/2 x plus 2, this one's already in slope-intercept. This first one, though, is not. We got to do some stuff to this first equation to get y by itself. So I'm going to rewrite it down here, and I'm going to say 1x instead of x. So 1x plus 2y equals 4. Now, this time, it's actually going to take 2 steps instead of just 1 in order to get it into slope-intercept. And that's because there's a number with the y. The y isn't kind of by itself, just waiting for the x to be gotten rid of. So if we get rid of this 1x, that means we're going to subtract it. So -1x minus 1x. And so that leaves us with 2y equals -1x plus 4. So what's the next thing we have to do to get y by itself here? This is something that we haven't done yet today. So what do we need to do here to get y by itself? Yeah, divide everything by the 2. Yeah. So everything gets divided by the 2. That's with this y, because we're trying to get y by itself. So divide by 2 all the way across. And what we end up with is y equals -1/2 x. 4 divided by 2 is plus 2. Yeah. If you notice, we couldn't tell by looking at these 2 equations to start off with. But we can tell now that we have this one in slope-intercept that this equation here, y equals -1/2 x plus 2, is the same as this one up here, y equals -1/2 x plus 2. We are going to graph this, but because it's the same line, the solution is infinitely many solutions because it's the same line. That's what we wrote on that first page. If it ends up being the same line, then it's infinitely many solutions. So we know the answer before we even graph it on these ones, which is kind of nice. But we still are going to graph it just to practice some graphing in general. But we have an infinitely many solutions here because those 2 equations are exactly the same. And so we're going to graph it. That's going to start at 2 on the y-axis. So there's our y-intercept. And then down 1 over 2. So down 1 over 2. And if it's the same line, we don't have to graph it twice. Go get a ruler from the bin up there as well. Yeah. Did you write that? Nice. That's awesome. All right, so number 4 is our first answer that is kind of one of those unique solutions, or no solution or infinitely many. We have an infinitely many solutions on number 4. Okay, let's take a look at number 5. So problem number 5, we're going to look at our last 2 now. Number 5, we have x plus 3y equals -15, and then we have y equals -7. So this first equation, definitely not in slope-intercept. What about the second one? What do we do with something like this, y equals -7? We've seen this a few times. Saw it back in Unit 4. Does anybody remember what to do when we see a y equals -7? So if I go back and we see y equals just a number, we get a horizontal line. So if you ever have a y equals just a number, that's going to be a horizontal line wherever that y value is. Now the opposite is true if it's x. It would be a vertical line wherever that x value is. You will see this as well. So let's go back here and we take a look. It says y equals -7. So let's start with the second equation here, because whenever you have just y equals a number or x equals a number, these are like the fastest ones to graph. We're just going to go down to -7 on the y-axis. So down 7, 1, 2, 3, 4, 5, 6, 7. Put a point. So y equals -7, put a point right there. And then we're just going to draw a horizontal line straight through that. Right there. So that is y equals -7. If it's just y equals a number, it's a horizontal line straight through the y-axis, whatever value that happens to be. In this case, it's -7. The other line, we still have to get into slope-intercept form and then graph it, but we're already done with one of our two lines here. So this other line, x plus 3y equals -15. There's going to be a little bit of algebra to work on that one first. So I'm going to say 1x plus 3y equals -15. This one's going to take a couple of steps. We have to get rid of our x first. So -1x minus 1x. And that'll be 3y equals -1x minus 15. We always keep the x term and the regular numbers separate because you can't add or subtract something with a variable and something without. That's why we're keeping those separated. And then the last thing we need to do here to get y by itself is to divide everything by 3, kind of like we divided everything by 2 on number 4. We're dividing everything by 3 here on number 5. And that'll give us y equals -1/3x, and then -15 divided by 3 is -5. So there's our slope-intercept equation right there. Y equals -1/3x minus 5. So if we graph this, we start at -5 on the y-axis, which is right here. And then from that point, we're going down 1/3, -1/3. So down 1/3. Right here, and then down 1/3. And so right there, I'm highlighting that point because that's where those two lines are going to intersect. I'll get my line drawn, and then we can figure out what point that is. We'll be good to go. So there are two lines right there on number 5. All right, so this coordinate here looks like I'm going over 1, 2, 3, 4, 5, 6. So x equals 6. And then we're going down 1, 2, 3, 4, 5, 6, 7. So 6/6 on the positive for x. So that's 6. And then down 7 would be -7. So the solution here is 6, -7. That is the exact location where those two lines cross. All right, the last one we're going to do, this one right here. Number 6. Our first equation, y equals x plus 5, that is in slope-intercept form already. We've got a slope of 1/1 and a y-intercept of 5. Y is already by itself, so we're good to go there. So let's just go ahead and graph that real quick. We'll start up at +5 on the y-axis and then go up 1/1. So 1, 2, 3, 4, 5 right there. And then we go up 1/1. We just keep following that same pattern all the way through one of those nice, perfectly diagonal lines. Did anybody work ahead and figure this one out already? Just out of curiosity. No? If not, that's fine. I was just kind of wondering. All right, so there's our first line right there. Y equals x plus 5, or 1x plus 5. Now the second one, we've got x minus y equals 2. So this one is not yet in slope-intercept form. So I'm going to rewrite this. I'm going to say 1x minus 1y equals 2. So we have to get y by itself. So a little bit of algebra, just like we've been doing on those other problems. So minus 1x minus 1x. That gets rid of there, and that'll be -1y equals negative 1x plus 2. And we still need to divide everything by negative 1. We have to get rid of that negative to get y by itself. So divide by negative 1 all the way across. Negative ones cancel out. Negative 1 divided by negative 1 is positive 1. So that equals, so that's y equals 1 over 1 x. And then 2 divided by negative 1 would be minus 2. So we have a slope of positive 1 and a y-intercept of negative 2. So we're starting this time at negative 2 on the y-axis. And then we have a slope of 1 over 1. So up 1 over 1, up 1 over 1. So again, we got this nice diagonal line going right through the corner of every grid line. And if we line up the ruler and we draw our line, what happens? Yeah, we got no solution on this one. And the reason is because those two lines have the same slope. First one had a slope of 1, second one had a slope of 1. If lines have the same slope, they're parallel. And we wrote down on the first page that parallel lines have no solution because they don't intersect. So on number 6, these two lines do not intersect, which means we have no solution. So you can write no solution, or you can say 0 with the x through it to say no solution. Either way, either one of those is good for your answer on number 6. So that's as far as we're going to go today with the notes. We're not going to finish up these last two. We could. I am going to do one thing, though. I'm going to show you on number 8 this first equation, x equals negative 2. Just as a reminder, when you have an x equals a number, that is a vertical line wherever that x value is. So x equals negative 2. We go negative 2 on the x-axis right there, and we draw a vertical line straight through it. So that would be the line there for the first line on problem number 8. I'm going to leave it at that, though, because I want to make sure you got some time to work on your assignment. In fact, you got 30 minutes, which is plenty of time, which means that if you would prefer to use this time to keep working on your tests so you don't have to worry about coming in during TAT. By the way, the next TAT I have is on Thursday because I have a meeting after school today. And then tomorrow, Wednesday, we have meetings on Wednesday. So if you want to work on your test today, that's fine. Or if you'd rather, or if you're done with your test, definitely work on the assignment. So